Hello and welcome to this video lesson where we'll explore rates and unit rates. Our learning goals for today are: I can express a unit rate to represent a given rate, including unit price and speed, and I can solve problems involving ratios, rates, and proportions. And our language goals for today are: I can talk about numbers using words like per, rate, unit rate, ratio, proportion, and proportional relationship. We're going to begin with a little experiment. You should do this experiment with a partner, so take a moment to find someone to work with if you can. Now, take your pulse and have your partner be the timekeeper. To find your pulse, take your first 2 fingers and place them on the side of your neck underneath your jawbone like this. You can also find your pulse on the inside of your wrist, right underneath the base of your thumb, like this. Count the number of beats you feel in 20 seconds. Now reverse roles. This time your partner takes their pulse and you time them for 20 seconds. Who has the faster heart rate, you or your partner? Your heart rate is the number of times your heart beats in 1 minute. Let's use our heart rates to define what a rate is. The first part of your heart rate is your pulse, or heartbeat. The second part is the amount of time we tracked while counting our heartbeats. In this case, we use seconds, 20 seconds to be precise, but heart rates are usually measured in minutes, which we express using the units beats per minute. For example, a common resting heart rate for 11 and 12-year-olds like yourself is 80 beats per minute. You measured your heart rate by counting your heartbeats for 20 seconds, though. How can you figure out how many times your heart beats in 1 minute? Let's use an example to figure it out. Adil counted 25 heartbeats in 20 seconds. This means Adil's heart beats 25 times per 20 seconds, which we can write as the ratio 25 to 20. We need to figure out how many times Adil's heart beats in 1 minute. To do this, we need to find an equivalent ratio to Adil's 25 to 20 ratio that has 60 on the right-hand side for 60 seconds or 1 minute. So let's just focus on the number on the right-hand side of the colon. Remember, we call the 2 dots in a ratio a colon. So we're trying to figure out what math operation we can do to 20 to turn it into 60. What operation would that be? Did you say multiply by 3? If so, you got it right. If we multiply 20 by 3, we get 60. So as we know, when we find equivalent ratios, whatever you do to one side of the ratio, you must also do to the other. So that means now we need to multiply 25 by 3 and put that number in the box, like this. This gives us the equivalent ratio 75 to 60, and we can express that as 75 beats per minute, which we write as BPM. When we compare 2 things with different units, we have a rate. A rate is a special kind of ratio that compares 2 quantities with different units of measure. For example, Adil's heart beat 25 times in 20 seconds, the ratio 25 to 20. We can write an equivalent ratio of 75 times in 60 seconds, or 75 to 60. So you can see we're comparing the number of beats to a unit of time, seconds or minutes. So 2 different kinds of units being compared to each other, that gives us a rate. Now, if we wanted to express how many times Adil's heart beat in 5 minutes, we could write the equivalent ratio 375 to 300 by simply multiplying each side of the ratio 75 to 60 by 5. We used the example of Adil's heart rate of 75 beats per minute, which was the same as 25 beats per 20 seconds, or 375 beats per 5 minutes. Each of these ratios is equivalent, meaning they describe a proportional relationship. Proportional relationships are relationships between two variables where their ratios are equivalent. We use rates to describe any proportional relationship. I hope you're starting to see the connections between ratios and rates. Now let's take a moment to talk about the word per, which is really important for rates. The word per means for each. And here are some rates using the word per that you're already probably very familiar with. We measure driving speed in kilometers per hour, which we write like this: km for kilometers / h for hours, km / h. We measure the cost of produce at the grocery store in cents or dollars per kilogram, which we write like this: $/kg. For example, I bought bananas for $1.72 per kilogram today. We measure download speeds in megabytes per second, which we write as MB/s. And we measure wages, or how much you earn, in dollars per hour, sometimes written like this, but for many jobs, we would write a salary in dollars per year. Now, you might have noticed that the slash symbol fills in for the word per. So when you see this symbol, say the word per, and remember that per means for each. I hope you've also noticed that most of these rates that we're using relate to speeds or costs per a certain unit. For example, the cost per kilogram of bananas, or the cost per hour of an employer paying an employee an hourly wage. When we compare two things with different units, we have a rate. And here are some examples of rates. We need 1 pizza for every 4 people at the pizza party. Bananas are on sale for $1.72 per kilogram. A babysitter earns $10 per hour, maybe. And there are 500 sheets on 1 roll of toilet paper. Notice that the last 3 rates all compare one quantity to 1 unit. 1 kilogram, 1 hour, 1 roll of toilet paper. We call these unit rates, and we can see that each unit rate compares a quantity or an amount to a single unit, like $1.72 or 172 cents to 1 kilogram, $10 to 1 hour, or 500 sheets to 1 roll of toilet paper. In each case, the value on the right-hand side of the rate is 1 unit. Let's see if we understand what unit rates are. Which of the following of these are unit rates? A heart rate measured in beats per minute. The cost of gasoline measured in dollars per liter. The amount of sugar in a Coke measured in grams per serving. Did you say D for all of the above? If so, give yourself a pat on the back because that's the right answer. Each of the examples is a unit rate because we're comparing the first quantity to 1 single unit of the second quantity. So, beats per minute is a number of beats in 1 minute. For example, Adil's heart beat 75 times per minute, or he has a heart rate of 75 beats per minute. The cost of gasoline is expressed in dollars per 1 liter. For example, $1.35 per 1 liter of gasoline. The amount of sugar in a can of Coke compares the number of grams of sugar. In the case of a single can of Coke, it's 40 grams of sugar per 1 serving or can. And that's why each of these is a unit rate, because they're comparing a quantity to a single unit. Here's a problem for us to solve together. 150 grams of beans cost the same as 250 grams of rice. How much might each item cost per kilogram? Well, here's one way to solve it. We know that 150 divided by 250, or the fraction 150 over 250, is equivalent to 3/5. And how do we know that? Because the greatest common factor of 150 and 250 is 50, and so if we divide both the numerator and the denominator by 50, we get 3/5. So, back to our problem. If 150 over 250 equals 3/5, that means the cost of the rice is 3/5 of the cost of the beans. Now, we decided that beans cost $25 per kilogram, for example. And we then multiply that by 3/5, we get 15, which means that the beans cost $15 per kilogram. All right, here's a challenging problem for you. This picture shows us Canadian speed skater Jeremy Weatherspoon of Red Deer, Alberta, who set the World Cup record for the 500 meters at the 2004 World Cup in Italy. To set the record, he skated at an average speed of 14.44 meters per second. Now, the white-tailed deer can run at speeds of up to 30 kilometers per hour. So, who is faster? Take a moment to figure it out and then come back for the answer. Did you say that Jeremy's faster? If so, you're right. If we convert the deer's speed from 30 kilometers per hour to meters per second, we get 8.33 meters per second, which is slower than Jeremy's speed of 14.44 meters per second. Therefore, Jeremy skates faster than a deer can run. I hope you enjoyed this video lesson on rates and unit rates.